Today we will discuss on the different types of stratigraphy. That is how the stratigraphy are how the stratigraphic record of any area. That means the rock record of any area are classified or divided on the basis of different aspects. The study of stratigraphy. Now, the first type of stratigraphic types is the lithostratigraphy. Here we study rock columns, the temporal study of rock columns on the basis of lithology. So that is why, as the stratigraphic study is done on the basis of lithology, so that is why it is called lithostratigraphy. Now, in lithostratigraphy, what we basically study? So in lithostratigraphy, we studying the lithological aspects of rock bodies. Lithological aspects means we study the grain sizes, we study the texture, that is shorting, roundness, color. Basically, color is a representation of the composition of the any particular rock. So basically, we study color means the composition of sedimentary rocks, packing, porosity. So all kinds of lithological characters which are formed and preserved during sedimentation, those are studied under the heading lithostratigraphy. We separate out certain levels or certain divisions within the rock column. So that is why it is called lithostratigraphy. Now the question comes, why we need to divide into certain divisions or into certain levels the entire rock column? It is because that we have a geological time span of 4.6 billion years of the earth. So to pinpoint any event within this entire time span, to precisely understand someone that during X time some incident happened, we have to divide it into smaller or finer divisions so that we can precisely point out that during which time of the geological time scale, or during which time of the entire 4.6 billion years certain events happened. So for lithostratigraphy, we divide the rock column on the basis of lithological characters, and on the basis of that we can uh, distinguish, or we can uh, divide the entire rock column into certain smaller units and pinpoint some precise geological phenomena, geological events. So on the basis of lithological characters, we divide uh, rock record, and we divide rock into the smallest unit, which is known as bed, which indicates a particular physico-chemical condition of deposition, that is the smallest unit, and successively higher units are member. That means a member consists of certain kinds of bed. uh, Higher member is formation, then group, then supergroup. So as we move from bed to supergroup, we are moving to successively higher lithological units. So in this way, from successively lower to the upper higher level lithostratigraphic units, member, formation, group and supergroup, rocks are divided. Now, one common thing between each lithostratigraphic units, that is they have some certain lithological homogeneity. So as you uh, can understand that together certain number of beds they conform a member. Now which beds are form member and which beds are not, that means only those beds are fall under a member which have a certain level of homogeneity, that means certain level of similarity, so that I can group them into certain higher level, that is member. Similarly, few numbers of members together they form formation. Now only those members are fall under a single formation which have certain homogeneity. Okay, now the lowest unit of lithostratigraphy is bed, but the fundamental unit or the workable unit of lithostratigraphy is formation. Now, why formation is the fundamental or workable lithostratigraphic unit? Because the primary reason or the main reason to consider it as the fundamental unit, because it is the lowest unit of lithostratigraphy which is possible to map, and the scale of map is about 1 is to 50,000 or 1 is to 1 lakh. So in a geological topo sheet map at 1 is to 1 1 is to 50,000 or 1 is to 1 lakh scale, those lithological units which are mappable and which can be separated from the adjacent litho units which have some distinct lithological characters, their upper and lower boundary can be easily traced, easily identified, that lithological unit is known as formation. So formation is the fundamental unit of lithostratigraphy and bed is the lowest unit of lithostratigraphy. Now, the boundaries of any lithostratigraphic unit. The boundaries means the boundary of any lithostratigraphic unit means the boundary in vertical section, that means across time, as well as boundaries in spatial distribution, that means in lateral boundary with adjacent lithological units. Where should we draw these boundaries? Two possibilities or two probable ways are there by which we can plot the boundaries or we can separate some litho unit to the other litho unit, where the first point is where a distinct lithological change is observed. Here we can precisely plot or precisely separate the litho unit from the other unit, such that here you can see the bottom one is the uh, clay bed or mud bed, and the upper upper lithological layer is made up of sand size particles. So there is a distinct size differentiation. The upper unit is made up of sand size particle, the lower unit is made up of clay size particle, and this boundary, the man pointing here, this boundary is distinctly identified by their differentiating size textural character. So on the basis of this size differentiation, a distinct boundary can be observed and well identified in the field. So this distinct lithological change can be plotted as the boundary between these two lithological units. Now, in place where the lithological variation is gradual. That means gradually from the sand unit they changed through the clay unit. And there are some intermittent when the sand clay are frequently changed. That means gradually a sand dominated unit changes vertically upward to a clay dominated unit. So you can see that there is no distinct boundary like the left one where you can plot or where you can draw the boundary. The changeover from sand dominated unit to clay dominated unit is a gradual way. So here you can plot simply one boundary, that is the, you can see that the upper portion is mainly dominated by clay, this portion is mainly dominated by clay, and the lower portion is mainly dominated by sand. Almost there is here in this portion no clay, and here in this portion no sand. So in the middle portion there lies a portion which is basically a 50-50 proportion. That means almost 50% is sand and 50% is clay rich. So if you just demarcate this entire sequence into two halves, so we can plot a single line in the middle portion of this mixed lithological unit. By this line we can divide the entire lithological column into two halves. The lower part is sand dominated, upper part is uh, mud dominated or clay dominated, and gradually the sand dominated units change to the mud dominated or clay dominated upper unit. Now if we, as there is no sharp boundary between these two litho units, if we divide the entire lithological or entire rock body into more finer divisions, then you can plot three boundaries. You can separate out the lower portion as the complete sand rich unit, the upper portion as a complete clay rich unit, and an intermediate portion which is a mixture of sand and clay. So here, with respect to the previous division where we divide only the sand dominated unit and the upper mud dominated unit, here we can divide the entire rock column, rock body into three units: the lower sand dominated unit, upper clay dominated unit, and the middle mixed unit. So with respect to the previous division, here we can pinpoint any geological event more precisely. So instead of dividing the rock column where there is gradational uh, changeover from one litho unit to another litho unit, instead of dividing them into two litho units, it is better to divide them into three litho units for better pinpointing any geological event. So where there is a gradational contact, gradational changeover from one litho unit to another litho unit, we basically arbitrarily fix the lithological boundaries. You may plot, some may draw lithological boundary here, some may here, some may here. So this boundary is basically an arbitrary boundary which demarcates or which indicates the changeover from a particular lithological unit to another litho unit. Now, for demarcating or for saying a formation, we have to say or we have to depict or illustrate a formation. We need a type section. Now, what is type section? Type section is a section where you can see the entire formation from top to bottom. That means the um, top boundary and the bottom boundary can be uh, clearly visible. That means the lower and upper boundaries can be clearly visible and well identified. Lithological characters are distinct so that we can separate it out from the adjacent litho units. On the basis of these two, and the last thing is that within this formation there should not be any discontinuity. That means the entire deposition within any particular formation should have continuous. That particular section, so basically if we say some in simple words, that should be an ideal section in which every character is best developed. That means the entire deposition of the formation is preserved there. The lower and upper boundaries of the formation by which we can separate it out from the adjacent formation can be clearly identified and clearly established. Lithological character can be distinctly different so that we can separate it out from the other. That section is known as type section. Now the type section is normally represented by some graphic sedimentary rock, and this will form the stratotype. That graphic sedimentary rock, which is the graphical representation of the original rock layerings, that is known as stratotype. And along with the stratotype, one have to precisely mention its geological and geographic location. Nowadays, geographic location can be easily said with the help of GPS, and not only the GPS, we have to also um, say the geological location uh, with the directions, roads, near areas, by which along with the latitude longitude we have to mention for depicting any formation. So that the other peoples can easily visit that place and can easily study those rock columns or those lithological units. So this is one ideal, or this is an example of a stratotype. So in map you have to pinpoint the location like that. Here it is plotted as a black dot, and the rock column is drawn in a vertical graphical log, and all the necessary things, latitude longitudes, are described in the figure, as well as when someone try to describe this rock column, they have to mention that. So that is the type section, or you may often call it a reference section. That is the ideal reference section. Now for every type section there should be name. So the type section is for the particular litho unit, that is for our case, that is for say for formation. So every litho unit is named in binomial way. Okay. That binomial means two names are indicated in the nomenclature. The first is the name given by the authority, that means who is describing the litho units of any particular section. According to his or her choice, he or she can give any name, but most commonly the name is given with respect to the nearest area, with respect to the river, with respect to any nearest hillock. That means with respect to any permanent structure. And the second part of this binomial name is the status of the litho unit. That means if it is a formation, if it is a member, if it is a group. Okay, so certain names, certain the first name demarcates the um, most commonly it is with respect to any permanent structure nearest to that section. That may be any place name, that may be any mountain name, that may be any river name, that may be any city name. Sometimes it is for any particular tribal groups. And the second one is the rank of the litho unit, say for example bed, member, formation. Okay, but previously in the older literature you may found some um, type sections or some litho units name as X sandstone, say for example Dakota sandstone. So Dakota is the place name where those sand body is bed exposed, and sandstone is the litho unit. But the problem is that by indicating Dakota sandstone, you can understand that in the place Dakota, this rock body is better developed and exposed. But the problem is that in the second part, when you are calling it a sandstone, you are not depicting or indicating the lithological rank. So it may Dakota sandstone may be a bed, Dakota sandstone may be a member, it may be a formation, it may be a group. So the lithological rank is not indicated in that binomial nomenclature. And many older literatures you may found these kind of names, but nowadays there is strict rules by which these kinds of litho units they are named following the binomial nomenclature, in which the first part is named after any fixed structure nearest to the section. Second part is indicating the rank of the litho units. Along with that, you have to mention its geographic locality with a graphic log and a proper description. After that, it can be called or it can be named as a type, as I previously told you. So all the procedures have to be followed, and then they should be published in a recognized journal so that scientific community can know that, and they have to recognize that uh, the intent of the event must be indicated or must be described in your description. The rank and category of the litho unit should be shared. Specification of name, that means two parts, binomial names, which I previously told you. Specification of stratotype, that means the graphical log. The boundary should be distinctly demarcated and distinctly illustrated so that I can separate it out from the adjacent litho units. And discussion of nomenclature background on which basis I give those litho unit a particular name. They should be well described, their age should be said, they should be correlated with the other places litho units, and they should be um, if possible they should their genesis, that means how they form, that can also one have to describe. So by following these all procedure, one have to name a particular section, a type section for a formation. Okay, now another lithological division or lithological part is known as facies. That is not basically a litho unit, but this facies term nowadays comes for particularly those sedimentologists who basically try to study the sedimentary environment. So facies is a rock group of sedimentary rock layers that have a distinct character so that we can separate it out from the others. Um, it differs from the coeval units. It should be mappable. um, they have some distinct rock types, that is characteristics of a particular environment, particular depositional condition, and they, along with the lithological units, as the indicate a particular depositional condition, so they are obviously distinguished on the basis of fossil content also. So as I already told you, nowadays when people try to study the sedimentary environments, they basically follow this uh, sedimentological unit, which is called as facies. That means a facies is a depositional lithological rock body which indicates a particular depositional condition. In the previous examples, in all the previous litho units, whether it is bed, member, or formation, there is no um, term or no indicative of the environment parameter. So whenever you called a sandstone body, you are not saying whether it is deposited by fluvial condition, whether it is deposited by aeolian condition, or it is deposited in beach condition. So the environmental sedimentologist, when they try to study the environments of deposition of any sedimentary rock body, they introduced a new term which is known as facies. Here, along with the lithological, all the characters previously described, you can easily see that is they have two distinct characters, mappable, particular upper and lower boundary. So all like all the previous characters which we discussed previously in the discussion of litho units, different types of litho units. Along with them, a new parameter is included here, that is the representing a particular depositional environment. When the environment is indicated along with the other lithological characters, then we call them as facies. And as you know that certain organisms are restricted to certain specific environmental condition, so along with the environmental conditional variation, my fossil content also varies. So every environmental depositional condition, that means every facies has its own distinct lithology as well as fossil content. Say for example, shallow marine facies, deep marine facies, aeolian facies. So whenever you called shallow marine facies, immediately you are telling to the listener that these lithological units, the lithological units or the lithology of these facies is sand, mud, shale, etc., etc., and they are deposited in shallow marine condition. But previously when you told certain formations, say for example what I told you, Dakota sandstone. So when you called Dakota sandstone, anybody in the world cannot understand by hearing the term Dakota sandstone that at which environment this sandstone is formed. Is it formed in aeolian condition? Is it formed in fluvial condition? Or is it formed in shallow marine condition? But in facies concept, along with the lithological, all the previously described characters, here the environment is taken into consideration. So that is why I call them as facies, like the shallow marine facies, deep marine facies, fluvial facies, glacial facies, like those. So a sedimentary facies or simply facies is a term assigned to a sedimentary rock unit referring to its distinct and specific identifiable characteristics produced by physical, biological, and chemical processes during the formation, from which interpretation of its origin, that means the environment, can be made. So hence a facies is generated during specific sedimentological conditions, that means specific depositional environment and associated process. So for this portion is well illustrated whenever you call certain depositional rock body by indicating or by depicting them to some facies concept. So you are telling them about the depositional layerings, their physical, biological, chemical characters, as well as with their depositional condition. Now coming to the Walthers law. Uh, in Walthers law, the scientist first told about the lithological variation, the relation of lithological variation in lateral spectrum as well as in temporal spectrum. According to Walthers law, he said that the lithological units what we see laterally, that means within a particular time frame, especially the lithological units what we observe, that are also observed vertically. That means with time, those lithological units which occur side by side, with time those lithological units occur one over another. So lateral variations are expressed in vertical column also due to succession of phases. The on those lithophases which are the product of sedimentary environments found adjacent to one another in the modern can occur superimposed in continuous unimpeded stratigraphic succession. That means here you can see that there are some lithological variation in the spatial scale, and that lithological variation in spatial scale is also observed in temporal scale. Again, the conformable stratigraphic succession, and there should be no gap, no erosion, no discontinuity surfaces should be there. The conformable stratigraphic succession faces that are now in vertical contact, they represent environments that were once laterally adjacent to one another. So to describe Walthers law, one have to understand two things. One is the sea level rise and fall, which basically represent the vertical movement of the sea level with respect to a particular point, and transgression and regression. So transgression means landward movement of shoreline, that means sea is encroaching more towards land, and the opposite is regression, that means sea is going back from land, that means more and more land area is now exposed. So two things are different. Often people misunderstand and say that the sea level rise and fall is synonymous with transgression and regression. No, there is a difference. Sea level rise and fall means that is with respect to a particular point in which the depth of sea column is indicated by this terminology. So when with respect to a particular point, if the depth of sea water level increased, we call them sea level rise, and if the depth of water level decrease, we call them sea level fall. That is nothing or very least related to transgression and regression. An area may suffer sea level rise and fall, but there is no transgression or regression. So for transgression and regression, the shoreline must be moved. For transgression, sea is more encroaching towards land. That means more land area is inundated by seawater. And in case of regression, sea is going back far from land. That means more and more land area are now exposed. Now, transgression and regression, that means movement of shoreline, whether shoreline is moving more towards land or more towards sea, that movement is dependent on two factors mainly. First is the rate of sediment supply, that means how much sediment is supplied to the marine basin by the fluvial conditions or other sources of sediment supply. And second is the rate of creating accommodation space. That means how much space is available in that marine basin to accommodate the supplied sediments. Now, this accommodation space can be of two types. One is eustatic, that means if, for example, you may thought that the entire ice mass of the world is melted. Nowadays, we are going through global warming, and almost every alternate day we are reading newspaper or scientific articles that the Atlantic ice mass or the northern polar Greenland ice mass, they are melted in a high speed. So if all these ice mass, frozen ice mass which occur in the land areas, they all melted. So this meltwater will now go to the ocean basin and they make some contribution to the ocean water. Now, as the ocean water receives more and more fresh water, glacially melted water, so the globally the ocean level will increase. And due to the ocean level or ocean water volume increase, globally the shoreline area of for each continent will move more towards landward side. That means transgression occur. So that is the eustatic phenomenon, that means a global phenomenon. Okay, along with that, this accommodation space so for is also increased for this increase global water level, because as global water level is increased, now more and more area is available for uh, sediment deposition. Second way of uh, creating accommodation space is the local scale. So if an area is locally subside tectonically, that means some kinds of faults happen and the area locally subside or locally uplifted. So if it is subside, that means more space is available for deposition. If the basinal condition getting uplifted, that means less area is now available for deposition. So in this local case, there is no global effect, there is no shoreline movement, but the accommodation space is being increased or decreased simply by just some tectonic movements in the marine basin and due to some local tectonic effect, and thereby accommodation space is increased or decreased. Okay, so that is called, or that is due to sea level rise or fall of any particular place without moving the shoreline, that is without transgression or regression. Now, the causes of sea level changes, as I already told you, that may be global, that may be regional or local scale. That means they are eustatic. Eustatic means when all the global, when all the ice caps uh, freezed in the landmass, they are melted. When there is more tectonic activity, more tectonic fragmentation, plate separation, when seawater temperature increased, as temperature increased, water becomes more lighter, so more volume of water will be there. Um, and lastly, exchange with water on continents. If all the continental trapped water are now they are going to the ocean ice, ocean water, sorry. And the relative changes, local scale tectonic effects, as I already told you, some upliftment or fall due to faulting, if there is any uplift or downfalling of any particular area, so that will either decrease or increase the accommodation space of any particular uh, place. So with respect to that, is sea level of any particular area, uh, it may happen that transgression will occur or not, that can be changed. As you can see that in this place, due to tectonic movement, your sea level which is occurred previously, sorry, shoreline which occurred previously here, that remains fixed, but due to tectonic movement, the point which lies previously here now goes to this position. So the depth of water column, the height of the water column above this point will now increase without changing the shoreline position. So here sea level rise without transgression. Okay. Here are the various types of sea level changing curves, and depending on the resonance, depending on the intensity, different order of cycles of sea level changes are there. As you can see in the first order cycle, that is almost in the eon scale. That means here the time range difference is much more, almost hundreds of million years. In the second order cycle, that is much finer. Here the time span for drawing or for depicting the sea level changes is tens of million years, and will successively lower or finer recording of sea level changes, that is 1 to 10 million years. That is the third order cycle. So you can see more and more finer undulations of sea level changes, and this entire third order cycle is only for the Cenozoic time. You can see the mark, that is only for the Cenozoic time. So what you previously see in the first order cycle, that the Cenozoic sea level curve is steeply increasing, here in the second order cycle you can see that there are some ups and downs, some minutes or very few ups and downs. In the third order cycle you can see there are lots of ups and downs, lots of changeover of sea level curve with time. So depending on our necessity, we are uh, taking or we are considering different order of sea level cycle curve. Now the sea level change and deposition, it is known that a particular sedimentary depositional um, unit, that means sedimentary deposition of any particular time, when we consider it as temporally, it is observed that a particular sedimentary litho unit, a particular litho unit is diachronous. Now how it is possible? Consider a simple example, a marine basin in which during time A some deposition occurs, um, starting from the near shore condition, near land condition is sand, then mud or shale, and ultimately to carbonates or limestone. So at time A this deposition occurs, that is this entire deposition, if I consider it a block of deposition, that indicate deposition at time A. So it is a time rock unit A. Now if sea level increase, that means transgression occurs, shoreline is moving more towards land. Now the same deposition occur, but starting from more towards landward side. So previously what, where my sand deposition starts to occur here, now sand deposition starts to occur from here. So again sand, then mud, then limestone. So this is deposition at time B, when sea level is at time B. Again, if again transgression occurs, again a time deposition unit deposited. sand, then shale, then limestone. So we are getting 3 time rock unit indicating deposition at 3 time intervals: time A deposition, time B deposition, and time C deposition. So all there may be different litho units, but one common thing is that they are deposited within a single time. Okay. Now, if someone try to observe the vertical succession of any particular area or of any particular point, what will they found? They will found that at the bottom there is sand, at the top there is shale, and it is succeeded by limestone. Okay. So what you see laterally, that is also observed in temporal pattern, that is also observed in vertical scale. That is the Walthers law. If there is no um, changeover, if there is no discontinuity, then in most cases what deposition occurs laterally, that is also observed vertically. Okay. Now that is the Walthers law. Similarly, if it is regression occur, then gradually the rock units are going to more towards seaward side. That means more land area is exposed. Here you can see in the at the bottom is limestone, then shale, and at the top is sandstone. So same case. If it is transgression occur, then at the bottom starts with sandstone, gradually goes to more finer or deeper water deposition. That means shale to limestone. If it is regression, then starts with deeper water deposition, limestone, then goes to shallower water deposition, that means coarser fraction of sediments, that is shale to sand. Now in this case, for transgression, if someone try to plot the litho boundaries, so on what basis we plot the litho boundaries? Based on similar lithology. That means we can draw a boundary here separating the same lithology, that means all the sand part. Similarly, we can draw a boundary here separating the shale part. So we can divide the litho boundary on the basis of these two litho boundaries. We can separate out 3 distinct lithologies. In the extreme left there is only sand, in the middle portion there is only shale or mud, and in the extreme right there is only limestone. Similarly in this case also, here it is above it only sand, this only shale or mud, and the bottom portion is only limestone. Now this is my litho boundary. So this one might be L1 and this one might be L2. So these one are my litho boundaries, and my time boundaries are these boundaries. This one is one time boundary, that is time C. This one is one time boundary, time B, and this one is one time boundary, time A. That means in this time all these 3 units are deposited. So from this picture you can see that the time boundaries and litho boundaries are mutually cross cut each other. Similarly here also, this one is time A boundary, the above one is time B boundary, and the last one is time C boundary. So again you can see the litho boundary cross cuts the time boundary. So that is why it is called that litho boundaries are, or litho unit boundary by lithostratigraphic boundary are diachronous. That means they cross cutting the time boundary. Another important thing that can be explained from this picture, that is how did you identify transgression and regression from a succession. So here you can see that when sea level is changing, your grain sedimentary deposition is now encroaching more towards landward part, and in a vertical column you will get that grain size is gradually decreasing from sand to shale to limestone. That means from shallower water condition or shallower water phases to you can get deeper water phases at the top. That means grain size is decreasing up through the sequence. So a transgression condition will depicted by a fining upward sequence. Fining upward vertical depositional sequence indicates that your sea level is gradually rising or transgression is occurring there. Similarly, in case of regression, it starts with a deeper water depositional condition, then goes into the shallower water condition with time. So, starts with limestone, then shale, then sandstone. That means grain size is gradually increasing up through the sequence. So, in case of regression, grain size is increasing up through the sequence. In case of transgression, grain size is decreasing up to the sequence. So in a vertical scale, by observing this grain size variation, we can predict whether transgression is occurring with time or whether regression is occurring with time. Now there are some limitations of Walthers law also, that only Walthers law is only applicable for conformable succession. That means there is no gap in sedimentation. It should be a continuous sequence. And the second limitation for Walther's law is that it is not always that the lateral sequence is represented in vertical sequence. Sometimes, due to some intrinsic physical properties of certain sediments, and they are transportation towards any particular direction is less with respect to the other units. Say for example, you know that clay or mud size particle are uh, more cohesive than the sand size particles. So if laterally clay and sand size particles are deposited, now with time movement of clay deposition will be less with respect to the sand size particles. So maybe laterally what you see for a particular time, with changing time, you may miss some um, sedimentary units, and due to this um, cohesiveness factor of certain litho units. That may be caused for some other reasons also, but it is often found that the lateral sequence may not always strictly followed or strictly found in a vertical succession. Now, as I first told you that this lithostratigraphic study starts with the sedimentary rocks or stratiform uh, layered units, but their igneous and metamorphic rocks are not included previously. But nowadays, when um, igneous and metamorphic rocks are also studied with respect to the stratigraphic point of view, and we know that igneous and metamorphic rocks are not stratiform deposits, so the rules of superposition is not followed in case of igneous and metamorphic rocks. So for those non-stratiform rocks, that means igneous and metamorphic rock bodies, they are now also studied with respect to the lithostratigraphy, and those rocks are called lithodemic units, and their basic unit is lithodemy. So like sedimentology, there is lithostratigraphic units, and the basic unit is formation. For non-stratiform bodies, for igneous and metamorphic bodies, it is called lithodemic units, and basic unit is lithodemy. And what I told you, that it is equivalent to rank of formation, that for stratiform deposit the lithostratigraphy and formation. For non-stratiform rock bodies, it is lithodemic units and lithodemy. So thank you. Hopefully this will help you understand lithostratigraphy. Goodbye.